Friends, today we are going to discuss a very important topic related to tank, that is how to measure the tank capacity. You know that if you measure accurately the tank capacity, then your inventory control and revenue, etc., will be accurately you can accurately manage. So that level to know how much fluid are there inside the tank is very important. So before going to discuss in detail of this tank capacity and how much fluid is there in actually, we have to know the some glossaries used for tank in the tank capacity, for tank capacity. That is, you see that is here the tank is a picture, depict the tank pictures. The tank picture, the top of the sail. This is the, you see, this is the top of the sail, the design liquid level. This one is the dotted line. This one is the designed liquid level. This one is the normal fill level. Normally up to this the liquid level will be there, and that is called the overfill. This above the normal filling, we can say it is the overfill protection level requirement. That is meter cube BBL. It is to be mentioned as at this much meter cube, or in bracket or BBL, or attomillimeter or inch, whatever may be. Then normal working capacity, that is also in meter cube or BVL, and then the minimum fill level, that much material fluid should be there inside that tank, and this is the minimum operable operating volume remaining in the tank. That is also again this one meter cube or BVL or millimeter or inches, and this is the top of the bottom plate at cell. Top of the bottom plate at cell. So this is the tank configuration. What is the BBL? What is the meaning full form of BBL? In a tank level control system, primarily in the oil, gas, and chemical industry, BBL stands for barrel, and it is a standard unit of volume, the standard unit of volume and volume measurement, where 1 BBL equals exactly 42 US gallon. 1 barrel means 1 BBL means 42 US gallon. Next is calculating the volume of the storage volume and storage capacity of a tank, the storage capacity of the tank and the volume. Then if suppose your diameter is D, radius is R, height is H, and circumference is C. So radius is equal to, we have mentioned it in feet, diameter is also in feet, height is also in feet, circumference also in feet, area is equal to that is feet square, that is pi r square area, and volume is equal to area into height. So tank capacity in gallon, how much it will be in the APS unit, that is tank volume, that is FTQ, into 7.48 gallon per FTQ on a per feet cube, cubic feet, cubic feet, and cubic feet. Then that will give you the tank capacity in gallon, and conversion factor is 1 cubic feet is equal to 7.48 gallons. 48 gallons. So if you multiply this total volume into the cubic feet into 7.48, that is gallon per feet, means cubic feet, that will give you the capacity of the tank. Next is, suppose this is a tank, its circumference has been given 42, height has been given 12 feet, diameter 13.37 feet, and radius 6.68 feet. So find the storage capacity and gallon of the fuel per inch of tank level. Per inch of tank level, how much the storage capacity in gallon. So if you see the diameter, the value is given, C is equal to circumference has already been given. Circumference is already given. So circumference by twice pi d. So you will give the diameter. If you divide the circumference by twice pi, that is 42, and your pi is twice pi 2 into 3.814, that is 6.68, 6.69 feet is the diameter. Find the base area, pi r square. So pi is 3.14, or radius is your 6.69, feet square, that will be give you the base area you are getting 140.5 feet square. Now next find the tank volume, the area into height. Area you have 140 into 5 into height is equal to 12 feet. So that will give you the multiply these two, it will give 16886 feet cubic feet is the volume of the tank. Volume of the tank. Now convert the cubic feet into gallon, that I know. Earlier also I have previous slide you have seen that one cubic feet is equal to 7.81 gallon. So this is the volume. So if you multiply it by the this conversion factor, you will get it the gallon, and that is 12611.28 gallon. Then find the gallon per foot. This is the this much gallon is volume is available in 12 feet. So if you divide it by 12, divide by the 12, so you will come to know the how much volume is there for per feet. So if you go to 12 feet divided by 12 feet, that is 1050.994 gallon per feet. And if you want to measure in per inch how much is the capacity, then you divided by again 12, because we know 12 inch is equal to 1 feet. So that will give you 87.58 gallon per inch. Per inch, this much gallon of fluids are there. So if you know the circumference, if you know the height, you can calculate the per feet how much material is there, and per inch how much material is there, fluid is there. Now tank gauging system. Tank gauging is very important parameters. We are normally used to measure earlier cases the tank level by different mechanical methods, but accurate measurement of the tank level, tank fluid inside the tank is very important to know, because this will control your inventory, this will control your revenue. Revenue. So tank gauging is very important. It is not only measure the tank or your level, it is to be corrected in respect to temperature. Temperature. Suppose if temperature is high, the volume of the fluid may come up. So you may be thinking that you are having a good quantity of fluids, but actually it is not. So that correction, every correction has been taken, has to taking care while measuring the actual quantity of fluid inside the tank. That is one call is tank gauging. Tank gauging is the process measuring the liquids in the bulk storage tank to determine the product volume, mass, and level. It is critical for inventory control, leak detection. If a leak is there, then also you can come to know. And overfill, if it is overfill or prevention in the industry, like oil, gas, chemical processing, and retail fuels. Modern system often called automatic tank gauging, ATJ. Whether ATJ system is there or not, that is very important for the important tanks which is having the petrol, the diesel, or other fluid, other important fluids, ammonia, etc. Important costly fluids are there. Their automatic tank gauging is important, reflecting that will replace the manual deep testing with continuous digital monitoring. It will not only replace the manual deep testing, but also it will continuously monitoring. You will come to know from the control room or from the local the how much level is there actually in the tank. Some definition that is core measurement. And advanced gauging system tracks multiple parameters simultaneously. It will give you the height of the liquid inside the tank, that is called level. Temperature, multi-point temperature sensor profile the liquid to help the condensate for volume change caused by the temperature. If temperature is high or temperature is low, then your volume of the fluid inside the tank will increase and decrease. That will so that much compensation with the temperature is required. Then only you come to know how much actual fluid is there inside. If any water is there, detect any separated water, detect any separated water, separated is there. That also will this if you tank gauging system, gauging system will tell you how much water is there at the tank. And then finally, and also the pressure and density, very important, how much density and how much pressure it creating. That is the calculate the weight, how much weight, mass, and exact density of the sorted product, of the store product, of the store product, this fluid which is stored in the vessel, what is its weight, what is its mass, what is exact density. That also come to know by this pressure, density, water bottom is there, temperature is there. Temperature also you have to measure for compensation level. That all this tank gauging system. That's why ATJ is very important for any tank. Now, common term technologies that which technologies you are going to measure the tank level. Now, different tanks require different types of measurement. Measurement instrument based on the different measuring instruments based on the chemical properties, vapor pressure, and safety requirement of the product. So, not all techniques will be applicable to take the measurement of the level, to take the measurement of the fluid inside the tank, because some may be corrosive, some may be high temperature. So different process you have to adopt it to take the actual measurement of the level. Radar. First one is radar. Non-contacting sensor. It will not come in contact with any fluid. Contacting sensor bounce radio waves of the liquid surface. It will bounce when it emit the waves. It will bounce from the liquid surface, and ideal for corrosive liquids. If corrosive liquid, if you suppose you want to measure, you put a wire or put a some float, then that may erode. But if you use that non-corrosive radio waves, that will go down and bounce back when it is touch the liquid. So for high pressure vessel and corrosive liquid, these methods, microwave radar method is very important for accurate method for measuring the level. Servo uses a small displacer suspended by a wire and a motor. There is a motor, and there some a small displacer, when a ball something like that is tied to a wire, and is run by the motor to physically track the liquid surface. Where is the liquid surface? You start the motor, the wire with fluid will come down, and when it is touches the fluid, you can come to know. Highly accurate for custody transfer. It is very important how much that is help you to know the how much level is there, physically. Then hydrostatic tank gauging, HTG. Hydrostatic tank gauging means it uses the pressure sensor near the bottom of the tank to measure the weight of the fluid column and infer the volume and density. So suppose your tank is full, so when you are measuring the pressure at the bottom, you will get certainly the high pressure. If you bring the level down, you will certainly get the low pressure. Like this, you have to convert the pressure into linear length, That will also give you the correct method, another correct method for measuring the level of the tank. And then magnetostric tip props. Magnetostric tip props. It's commonly used for gas station. Floats rides along the vertical rod. One float will rides along the vertical rod to track the product, where the product is, and water level precisely using the magnetic pulse. So these are the process with which we are different fluids require different process. So you have to adopt different process for different fluids to get the actual level of the fluid inside the tank. Technologies is manual gauging. You can do the manual gauging, float and tape gauging system, servo tank system, ATGS, a servo tank, we have already discussed servo tank. What is servo tank? The motor with a where it will go down, float is go down. When it touches, you will come to know. Servo tank gauge system. Then radar, I have already explained. That is the signal will go. It will touch. It will echo back. You have to collect the signal time, and you will come to know how much level is there. Hydrostatic tank gauging, that I have already discussed, that because it will measure the pressure at the bottom of the tank. And hybrid gauges, that we'll discuss, it is a combination of hydrostatic plus radar or servo, that will give you the accurate measurement. These are the manual tank measurement. These are, you see earlier we are using deep rod. In that, suppose you have to dip it inside the fluid, and you will come to know, it will touch the bottom, and you will come to know, and you will take it out, and the liquid will adhere to the surface. You will come to know how much actual level is. Then there is a float system. It is the float. It is moving. It is tight between two wires. The two wires are tight at the bottom, and as per the it is resting on the fluid. As per the fluid level, it will go up. The wire will go up through the pulley system. This is the indicator. It is tied to the indicator, and indicator will give you signal how much level is there inside the tank. This is the tube level gauge. This is mounted on the tank itself at the bottom. One is at the top, and the actual level will and the liquid will flow through this from the bottom, and it will give you the actual level, because water are maintain equal levels, equal levels. So this will give you the actual level. If you whatever level you are seeing in the tube, that is the level of the tank. And this is the gauging tapes. When this big is not float is not possible, you can directly drop the gauge through a wire, through a tape, and you can measure how much length of the fluid is there inside the tank. Now, one by one, I will discuss ATGS. The servo tank gauging system is a highly accurate servo tank gauge is a highly accurate mechanical electronic instrument used for continuous liquid level measure. Continuous, it measure the liquid level continuously in a bulk storage tank. It is the industry standard for custody transfer and high accuracy inventory control in oil, gas, and petroleum sector. The method easily achieve an outstanding accuracy of plus minus, you see, 0.7 millimeter level difference is there. That also can be measured with this servo tank gauging system. Turbo tank gauging system, it is a combination of mechanical and electronic. This is the mechanical float. It will come. It is the mechanical float servo. When it is through motor, it will come down, and when it is touches the fluid, due to buoyancy, your weight will come down, and you can come to know how much is the level. So the servo tank gauge operates on the principle of buoyancy, Archimedes law. A small displacer, this one is called the displacer suspended on a measuring wire. This is the measuring wire. This is the measuring wire. Is lowered into the liquid by servo motor. By the servo motor, lowering the motor. When the displacer touches the liquid, there is a tension due to its own weight. When it touches the liquid, its apparent weight decreases, because liquid will give some buoyancy force. When it is not touching, it is due to its own weight. It will give some tension to the wire, and when it will touch the liquid, it will give the buoyancy force will act on this, and then your tension will decrease. Weight will decrease. Those sensor detected this weight change and command the motor to adjust the displacer position and maintaining an exact balance. So maintaining an exact balance. And there is a temperature props are also there. The temperature props are there. These two are connected. Here with the AC power we are giving to the servo motor, electronic device, and here the AC to convert to DC, and then here the temperature also, we are measuring the temperature. So if temperature is there, that much compensation with the volume it will take place, and this will one will give signal to the outside locally how much actual level is there, and another signal will go to the system, to the control loop. This will give you the level of your tank. This two wire IS heart. What is the two wire IS heart? Now the function two wire loop. Now gauge receive DC power. This gauge receive DC power, and the AC is coming, the AC is converted to DC power, and communicate digital analog data over the exact same pair of wires, with the same pair of wires. The intrinsically safe. IS means the intrinsically safe. IS means this IS designation means the circuit is designed with low voltage. This circuit here, which is connected, is a very low voltage and current, and preventing any spark. There will not be any spark or thermal ignition, even in explosion or highly inflammable tank environment. It will, if it will not give, as the electric system is there, it will not give. It is a high, it is a intrinsically safe, means it will not give any spark, so that the vapor, there should not be any fire inside. Very safe. And heart protocol means, that is the instrumentation, the heart signal. Heart means your, I am telling you the meaning of the heart. Heart is called the um, highway addressable remote conducer. Highway is when highway, highway highway addressable remote conducer. It will give signal. It will operate between the signal 4 to 20 mega amperes, microamperes, in between this and this signal, according to the level. It is 4 means 0, 20 means maximum. Accordingly, it will give you the signal. It enables remote configuration, and give you the level of the tank at site locally, as well as to the control room. And it is operating in both electronic as well as the mechanical fluids is also there, and it is acting on the principle of Archimedes, because it has having some weight. When it touches the fluid, weight will come down, and you will come to know where is the level is. Then radar. Radar is very important, because I have told you, it will not, if any fluids are there, suppose it's very corrosive, there cannot mechanical, any item cannot be used. There radar will give the signal. Radar are highly reliable, non-conducting devices that measures the level of the liquid or solid in the tanks and silos, that emits microwaves. This will give you the microwaves. When microwaves travel, it will strike the level, or fluid, and then bounce back. And then the time taken will, going back, coming down and going back. That will give you, with the velocity and divided by the time, that will give you the length of this tank. That will give you the level of this tank, the full level of this tank. And what is GRH? GRH means the gauge reference site. This is the maximum where this radar is mounted, and this is the bottom. This is the bottom. Within this range, this radar will give you the level. Radar will give you the signal, and you come to know what is the level of the tank. This is the radar. Then a hybrid tank gauge. A hybrid tank gauge combines a continuous level gauge like radar. You have to, either you have to, both radar or servo, any one of them, and then hydrostatic tank gauging. Means it will measure the pressure, pressure transducer. It will measure the pressure at the bottom of the tank, and that will give you the level, and that will give you the signal, how much pressure is. If level is down, you will get less pressure. If level is high, you will get high pressure. So you will come to know the level. And along with this, the radar is also there, or servo gauge is also there. Then compare the both and give you the actual level. Chemical, so it is frequently used for petroleum and chemical industries. Then you see there are two recognized methods for measuring the level, or one is for volume measurement of the level, based on the level and temperature measurement, and another one is based on the measurement of the hydrostatic pressure, because you are getting high pressure when tank is full at the bottom. Hydrostatic pressure, that these two, that will give you the mass base. This is give you the mass base, this will give you the volume base. These are two. And you see the tank, this is from here, this is the reference point, that is a gauge reference height from here to here. That is the vapor phase. This is called ullage. There is no fluid is there. And from here to the bottom of the zero level bottom, that is called innage. So what is tank ullage? Ullage is the empty space between the surface of the liquid, and the fixed reference point. And the fixed reference point is the GRH, fixed reference point at the top of the tank. And in H, it is the actual depth from here to actual depth of the liquid in a storage tank measured from the bottom of the tank to the liquid surface. This is called inch, this is called ullage. These are the two important scientific, two important definition to term we are using for tank to measure the tank level, vapor level as well as the liquid level. Then tank gauging, there are, so I have told you the different fluids, different type of measurements are there, and these are the different type of material. Asphalt viscous, very viscous, mostly solid. If the temperature is increased, then it will be lightly viscous. So this is also one type of fluids, that is then crudes, then black oils, then white oils, LGP, aggressive, high temperature oils. So float, you see here it is as it is solid, so highly solid, semi-solid. So you cannot use float. So there you have to only in crudes or black oil. This float can be used like this. Not used LPG. Floats are not used. High temperature also it can be used. Servo, I have told you. Servo means the that is combination temperature correction is there, and mechanical means fluids are not fluid, the balls are there, it will move along with the motors, and that is suitable for this and good for this. Servo is good for crudes, black oils, white oils. You see LPG, it is good, but depending on the aggressive fluid, depending on the aggressibility of the fluid, not used. Then radar is the system by wave, we are using the wave technique, we are using to take the measurement of the fluid level. That is good for every, you see, for asphalt, it is good for every level measurement. Every level measurement, radar is very important measurement for taking the level measurement. Then HTG, HTG I have told you, that is a high tension, high pressure, HTG. HTG, I have told you, you have seen the HTG. HTG, the pressure, we are measuring the pressure, measuring the pressure. Hydrostatic tank gauge, hydrostatic tank gauge. HTG, HTG, there is no liquid phase, so that's why it is not used. HTG not used. Limited, it is very limited use. So limited level accuracy, and also only the you are measuring the pressure. So to convert the pressure into linear height, slightly different, but you can compare when you are using a hybrid system, you are using the HTG plus servo or ladder. That is good, 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 good. Everywhere it is good. So this is either this or radar system or servo system you can use for actual a measurement, actual level of the fluid inside the tank. So I think I have covered the tank gauging system very well to you. Different types of level measurement, mechanical also I have explained all the mechanical devices we are using, and all other devices also instrument are using for taking the measurement of the water level or a fluid level, its correction, temperature corrections. So if you go through the slides, your concept will be totally clear. And that is very important, because how much material is there, how much fluid is there inside that tank is very important. That will control your inventory, that will control your revenue. You may not be, but if you are thinking that high temperature, you are measuring the volume, that will give you a wrong impression that you are having a much more material fluids, but actually it is not. So all these measurements are accurate. You see the radar or the servo, it can accuracy 0.07 millimeter. So it is very accurate measurement of level is possible. So this will help to control the inventory as well as the revenue. So so if you are satisfied, you go through the slides. If you are satisfied, then give a tick mark and subscribe these channels, so that next in your next post, when you are going to discuss the design aspect of the tank or other, there are two three posts will be coming for the tank, special purpose tank, etc. You will come to know. And if you are satisfied, you can you can you can tell your other friends, graduate engineer trainee or experienced person also. If you go through this discussion or that slides, your concept regarding the level measurement will totally clear, and you can face all any interview board, anybody, any ask any question, you will be able to reply. You reply it very well. Both instrumentation, mechanical will be highly benefited if you are going through this. Going through the going through this post. So if you are satisfied, I will requesting you subscribe it and make it more familiar, or to ask your other friends also, so that they can also be benefited. Thank you very much. If are still any doubts is there, you can mail me or telephone me, or can arrange a online training system, so that your any doubt is there, it can be cleared. Thank you very much.